Introduction to thermophysics. Now, the word thermo means heat. So in this section, we will be studying about heat. So now, we know that we learned in chemistry that matter is made up of tiny particles that are in constant random motion. So the kinetic theory of matter states that the first bullet, matter is made up of tiny discrete particles. The number two, each particle of matter is continuous random motion. The number three, there are forces of attraction between particles, and these forces we call them cohesive forces or adhesion forces. So those that are cohesive, they are those forces between particles that are similar, we call them cohesive. Then particles that are different, we call them adhesive. So now, as we introduce this kinetic theory of matter, we should understand the changes of state of matter. So the first point you should know is about melting. Now, melting simply put the change of state of matter from solid to liquid. So why does it change? A solid changes to liquid because it gains enough average kinetic energy. And so because of that, their movement becomes a little bit faster. Then we are talking about freezing, which is solidification. A liquid changing to solid. You put water in a fridge, then it becomes a solid. Vaporization, it's when a liquid changes into gas. And here the particles, what happens is if they gain enough energy, they escape from the surface. Then condensation, it means gas changes to liquid because it is losing energy. And then sublimation is the direct change of a substance from solid state to gaseous state, or the vice versa. So these are the changes of state that you should know that matter undergoes. And this tells us what happens during evaporation, heating, and cooling of a particular substance. So now, we talked about evaporation. So what you should bear in mind is that there is a difference between boiling and evaporation. So what you should know is that for evaporation, it takes place on the surface of the liquid because the liquid gains energy and then they start to evaporate. Then talking about boiling takes place within the liquid. And then you should also understand that when it comes to boiling, usually boiling takes place at a certain temperature, but for evaporation takes place at any temperature. In evaporation, there are bubbles that are produced, but in boiling, there are no bubbles. Now, is it true that cooling can cause evaporation? So there's an experiment that you can do to find out. If you see you have a pump. In this case, it's a bicycle pump. Then this is a beaker. You put ether. Ether is an organic compound. So now you want to find out, does it really mean that when you cool something, it causes evaporation? Okay, let me say, does it really mean that when something is evaporating, then it causes cooling, in other words? So what you do is you start pumping the air into the ether. So remember that the particles there on the surface of the ether gains enough kinetic energy and they start escaping. So meaning that if they escape, they are making those that are remaining losing energy. And the result is when you remove this beaker from the table, you realize that there are some ice that are going to be formed under the beaker. So what does that tell us? It tells us that when you evaporate a substance, it causes cooling. So this is what we call the cooling effect of evaporation. So you should bear that in mind. Now, another concept we would talk about is gas pressure. Now, we should understand that when we are talking about gas pressure, we are talking about the gases, particles exerting pressure on the walls of a container. How? So they exert pressure on the walls of a container by colliding with themselves, or they can collide with the walls of a container, thereby increasing the gas pressure. So this is what we mean when we talk about gas pressure, meaning the gas particles collide with themselves as well as with the walls of a container.